I think that security people as an industry should spend some time, not just in operations, but also in development, to really understand the pain that developers have in writing code. It's not, it's not that developers don't care about security, they can't write secure code. But you sit with developers for a long time, and you start seeing all the competing needs they have, all the priorities they have. I work with one organization that said, we found a security bug. Customer came to us and said, we found a problem in this software package. And I went to the VP of engineering and said, we need to patch this right away. This is really critical. And he said, well, how much money are we going to lose if we don't patch it now versus if we don't patch it in 6 months versus if we patch it in a year? I said, and he said, okay, so here's what you need to understand. This was early 2000s. Every time we do a major product change, and what you're asking for here is a major project change, and we need to do at least one, if not multiple, full regression tests on our product. That takes 2 weeks. Then, 15 years later, we've improved a lot since then. But it takes 2 weeks every regression test we do. We have contracts with customers to deliver our products on certain schedules. We will miss those schedules with every regression, about 2 weeks every time we have to run an unscheduled regression test. Are we going to lose $2 million, $50 million, $1 billion on this? I need some way of quantifying this so I can understand how much abuse I should put our customers through for this fix. And I had to look at it and say, you know what? Next release cycle will be fine. Just add it in with everything else. And he said, hold on a second. Which feature should I cut to do this? Where does this fit in the general scheme of things? And we talked about it. It was a relatively small change, so we didn't need to break anything else out. But there's all these other competing requirements. So I started thinking about this. I thought, if we really want to do security better, we need to find ways to work with the business to do this. And then I started looking at breach data. Alex in the audience used to work at Verizon on the breach report. You look at all these, their breach report, you look at a lot of other breach reports that are out there. And consistently, the problems we're seeing that are leading to breaches are not high-end malware. These are not sophisticated, persistent attackers for the most part. This is, oops, I didn't disable a default credential. Oops, I didn't disable someone's account when they changed roles within the organization. So like the Society General issue from a few years ago. This was a trader who had been in the back office. And then he moved to the front office as a trader, and then he moved back to the back office, into the front office, back and forth several times. And so he had intimate knowledge about how all these systems worked. And every time he changed roles, they left him the access he needed to control both ends of the system, which meant that he could manipulate the systems so like he was doing his job, when in reality he was violating all sorts of internal controls and policies. But he had the ability to solve that. That ended up costing Society General, I think, $2 billion? Something to that effect. This was not complicated. This was not a need to make bug fixes. This was simple change management at its best. So what I'm going to talk about today is some of the basics we can back to do a better job, both from an operational perspective and from a development perspective, where we can make things a lot more secure for ourselves and for our customers and our organization without making our users or our customers, in some cases, go through more pain and suffering, and without impacting, in a lot of cases, development life cycles, product delivery times, and things like that. So that's what I'm going to tell you about today. And so that's the good news. What's going here, it's not rocket science. You don't need a PhD to do this stuff. You just need to think about how you're doing this stuff and change your processes a bit to make needs. So this has come up in several talks today, and I know it's going to come up again tomorrow, at least in my panel that I'm doing tomorrow. Patch management. People are really bad at patch management. Aaron and Zach talked about it earlier today as well. This is a really basic thing we have to be able to do. And it turns out at scale, it's actually kind of hard to do, but people don't want to spend a lot of time and effort on it because it's hard and it's not sexy. You don't get to go to, as a general rule, you don't get to go to conferences and talk about the great new tool you developed for doing patch management. You get to go to conferences and talk about the sexy new thing you did to stop the latest whiz-bang web attack, or the cool new malware injection you did. This is important stuff, and we should be researching it, we should be doing that. But if you're an operations person, what you need to worry about is the things that are most likely to impact your organization. And the things that are most likely to impact your organization is not a really cool hack on a smart meter, unless you work for the power company, or you have fancy parking meters, and you work for some city that has implemented them. What you care about is, can I effectively reasonable time frame. So, I mean, there's some great tools out there. Look at them, Chef, Puppet, Microsoft has some fantastic tools. It's a discipline. We'll talk more about the DevOps tomorrow, and I'll talk about DevOps a little later. This is not rocket science. You just got to do it. People will tell you, use CVSS, use those rankings. Earlier this summer, Ed Bellis and Roy from Skynet did a great talk demonstrating that CVSS ratings, aside from a 10, are actually kind of useless. You're better off randomly selecting a patch and saying, I'll deploy that one, than using a CVSS rating lower than a 10. It's just not, it's a terrible measurement scale, and the attackers don't care. They're actually going for lower risk ones per se, because they're easier, in a lot of ways they're easier to exploit if only because people are patching other things. What becomes more important is Josh Corman, 2-3 years ago, coined the term HDD Moore's Law, playing on Moore's Law CPUs and transistors and whatnot. And what this was if the bar you need to be able to get across when you're doing patch management, configuration, and security in general is, can you protect yourself from anything for which there's an exploit in Metasploit? That's the minimum bar you need to get to. And so, if you're below that bar, then you're in a world of hurt, and you need to be working on your patch management, configuration management, your general security program in general. And I'll get to configuration management next. But it turns out if you combine the CVSS 10s and anything that's a Metasploit and patch for those first, you improve the quality of your security by 30%, your chances of avoiding an exploit by 30%. If you just choose randomly or use CVSS alone, I think it's 2% over not doing anything. So that's an easy thing to do. Just for prioritization of patches, look at what's in Metasploit, look at what's rated as CVSS 10, and you just, vastly improve your chances against an attacker. Simple as pie. Patch management, by the way, is mandated under PCI in every single compliance framework that has ever existed or will ever exist. You have to be able to demonstrate you can do the patch management. So there's a lot of incentive there. By the way, incident response is a lot more expensive than patch management, even in the short term. Additionally, so related to patch management is configuration management. I talked a little bit about that. So configuration management, it turns out, I talked about this last year as well, this is a super important thing that you need to be able to do. You can't secure your organization if you don't know what systems you have, so inventory management. And you can't apply your patch management if you don't know what software you have, what version it's at. So you need to know if you have to apply that patch or not. Fortunately, there's a lot of tools out there. Historically, this has been a really, really hard problem to solve. There's a bunch of commercial tools, and frankly, they're all terrible. They're really hard to use. They are. I mean, they're really incredibly painful to use. The only thing that's more painful to use is a GRC tool, like Archer. And they're hard to keep up to date. You get to configuration drift. So configuration drift is where you've documented what the state of your system is, and then slowly over time it changes, but you're not keeping up with that. So you don't actually know what your configuration is. And this causes not only a compliance problem and security problems, but also just general operational problems. You have a system, and it dies. How can you recreate it if you don't have an up-to-date idea of what that configuration management is? Fortunately, in the last few years, there's been a variety of open source tools, most notably Chef and Puppet, but there's CF Engine, and a handful of others as well, that automatically track this stuff for you. Mostly for the purposes of systems management, but effectively that database becomes a configuration management database. As an added bonus, you get automation, you get patch management, so suddenly you have the ability to consistently manage all your devices. You now know that all your web servers are running the same version of Apache or ISS or whatever Nginx, whatever you're using for your web servers, which means that when you now know everything's up to date, that improves your chances of compliance and improves your chances of security. Again, not complicated stuff. However, it does require changing the way you think about systems administration and how you think about security. You're now thinking of infrastructure. The term people are using is infrastructure as code. You need to be thinking about process-oriented systems administration, if you will, rather than manually doing it. A lot of folks here, there are new SSH workloads. It's not much more complicated than that, except for you get the advantage of you get a lot of tracking over when things fail, how they fail, automating the retries. So you have a much more consistent environment. And the cool thing is you also get tripwire-like functionality. If someone logs into a system and manually changes it, well, you have a compliance problem. you have a security problem potentially as well. You lose track of what your configuration is. What tools like Chef and Puppet will do is say, I am the master database of what is the configuration for this web server. If someone logs in and changes, it'll automatically shove it back to the document to the way it should be, as far as it's concerned. So this helps prevent, even if a malicious person manages to break into your server and start changing configurations for their benefit, and within whatever your agent's window of opportunity is, generally half an hour, it gets shifted back. So that's sort of a self-healing environment, if you will. And then you get a warning on that. And I talked about change management. Every time one of these things happens, these tools document who issued the run command, what the command was it issued. And if it pushes things back, it generates an alert. It generates a log of what happened. So now you can generate alerts and notifications proactively telling you when something is going wrong. And that can be an email, it can be an SMS, it can be a notification to your alerting system, like a PagerDuty or whatever you're using in-house. And suddenly you're getting automatic notifications of what's going on. You're in consistent deployments, and you know exactly what you have. So whether if the Business Software Alliance shows up and says, show me all your copies of Oracle, prove their license, or it's just that you get the latest patch bulletin, from whoever your Linux provider is or whoever your application provider is, and says, you need to deploy this. You actually know where you're deploying it. It's not, you're not just blindly guessing and hoping you have all the right things. There's also some benefits in terms of consistent deployments from when you start doing continuous deployments or things like that. You have an application developing, let's say, your dev environment, your QA, your pre-production, production environment. You know you're running the same exact version of the software every step of the way. So you already that drastically improves your chances that if it works in dev, it's probably going to work in production. Because you know you're running the same version of the web server, the same app server, the same version of your Java runtime environment or your Python environment, whatever it happens to be. And this is, these are the places where things tend to break in that dev to production cycle. So you get faster production times, more successful upgrades. There's all sorts of side non-security benefits you get out of doing good configuration management, systems automation. And by the way, you can start doing some metrics on this so you understand. You can actually say, I deploy patches to 98% of my servers within 4 hours, and 95% of my laptops or desktops in 2 hours. So you know exactly what you're doing. You can then define, you can then say whether or not you're being successful. You don't have to say we're failing or we're succeeding. You can say, I am meeting my business need successfully or not. And then if you're not, you have some ways of working to improve that or not. And that plays well into risk and stuff. And I think Alex will probably talk about that tomorrow in the panel. So then comes the one that really hurts the most, identity management. By far and away, one of the biggest sources of breaches is poor identity management practices. I talked about it a little bit earlier. But it comes down to people having too much authorization. It's not just an authentication problem, it's an authorization problem as well. People's accounts not being taken away when they change roles in the company. People's authorization, even if the account is closed, well, if the account's closed, it's not a problem. But then you still need to account that system, they maintain that authorization for doing things they're not supposed to be able to do. That's a problem. And then when you start dealing with things like cloud providers and outsourced environments and multiple applications, traditionally what happens is each application becomes its own identity management endpoint. Every time you add an identity management endpoint, a place to create a user and set authorization, your job as an identity management person increases exponentially. It becomes increasingly difficult to do that provisioning and deprovisioning of users. And there's some solutions here. Yeah, I think probably everyone here uses LDAP or Active Directory in the organization probably. That helps from the authentication standpoint. More sophisticated applications let you leverage authorization and capabilities out of there by saying, oh, if you're a member of this group in Active Directory, you get access to this functionality. You still need a process for dealing with that, changing the groups when the user changes roles. So you need some notification, you need some business flow, you need some workflow going on there. It's not sexy, it's not fun, but this is actually where you save money, this is where you actually make your organization more secure, even though it's boring. And I think that's one of the big things in operations. Most of security operations is really boring. So you should automate the smile. On the authorization front, there's been a lot of work recently on the cloud side using Skin and on internal applications using XACML for doing centralized authorization management. Something to keep an eye on over the next couple of years. Increasingly, the big packaged applications like the Oracles and the Siebels, people PeopleSoft and things like that, SAP will start supporting it, and then you really have the ability to centrally manage all these permissions in a secure way. So definitely something to look at there. The only other issues, and this is more of a problem when you're turning off a user, you're terminating a user who may be malicious or something like that, is in most of these environments, disabling a user does not terminate their existing sessions. So that's something to look for, particularly in a situation where you have, like I said, you may have an employee who's a little touchy. You need a process for when you're terminating an employee who may be apt to do something malicious to make sure that not only are you terminating access, but that you have a way of going into those critical applications and terminating those live sessions. There's most of these things don't have a single sign out. If you have a single sign in, that's awesome. But there's no single sign out. A really good example of this is OAuth. Who here's played with OAuth at all? Anyone? If you do Twitter on your phone, you use OAuth. If you do Twitter on any device other than the website, you've been issued an OAuth token. Facebook does this. Most of the web applications these days who allow you to authenticate from a mobile app. When you sign in, what you're actually doing is authorizing your device to act like you. Now the OAuth spec is kind of interesting here. It does not specify whether, when you do a password change, whether the token needs to be invalidated or not. And depending on the situation on why you change your password, the correct answer may be de-authenticate all tokens, or maybe not to. So in the case of, you get a notification from your application provider, our password database was compromised, you need to change your password. There's no reason to disable those tokens on all those devices when you change your password. Because your password is not in that token, you still control those devices. On the other hand, if you lose your iPad, your tablet, your phone, first thing the instinct is to go change your password. That does not, in the case of Twitter and Facebook, disable that token. So if someone gets a hold of your device and they launch that application, they have access to your stuff. And no matter how many times you change your password, it does not impact that token. Instead, you need to go into the web interface and manually disable, deauthorize that device. And both things make logical sense, and depending on who the user is, they may have different expectations. And so this is not technology, this is a documentation problem. If you're using OAuth in your organization, you better figure out what's the appropriate way to do it for your application. And then make it clear when someone changes their password, whether or not they're going to, on the screen, password change. You need to go log back in on all your devices. Or if you lost a device, go here to disable that token. Not complicated. Two lines on the page, on a web page somewhere, that's easy for the user to find. Problem solved. Particularly when you're dealing with, say, compliance-related data on a mobile device. Oh, by the way, I have that healthcare app on my iPhone. I'm a doctor. I lose my phone gets stolen. I change my password. I'm good. HIPAA. No, there's no HIPAA violations. There's no violations of other healthcare law anywhere in the world, except for the fact that that application still has access and someone may be gathering patient data on your part. But I think that this is like one of the hardest problems in security today. I would claim it's harder than just about anything else from an operational perspective is doing identity management well. So it's not surprising we're bad at it, but we're also not trying very as hard as we could. A bunch of folks have talked about logging, auditing, monitoring. We're terrible at this. We don't centralize the logs. We don't deduplicate the logs. We don't look at the logs at all. And very few groups who don't look at the logs, even for process or drills or anything, to deal with that data when they need to look at it. They get notified there's a breach and like, I have 18 terabytes of data and I have no idea what to do with it. None. And so yes, you may not have, a $5 billion budget or a $50 million budget for building an entire incident response team whose job is 24/7 to monitor this. That's okay. But there's a lot of basic patterns of breaches out there. Some of those you can configure your log collectors to look for, and some of it you just need to know what to look for and how to process and practice it periodically. So when you do get notified, you can actually respond in an effective way. There's some great tools out there. Splunk, everyone, Splunk's here. It's a great tool. It's awesome. It's expensive. especially if you're a small organization, there's just no way you're going to be able to afford it. And that's fine. Aaron and Zach talked about, Logstash. That's a great tool, especially you can combine with something like Elasticsearch. You can mimic some more functionality. You can build a data warehouse. There are ways of doing this. There's some great folks here who've done similar things around this space. Talk to them. Talk to Alex if you want to hear about data warehousing and security stuff. These folks are doing great stuff. Alex is turning really red right now. It's kind of cool. Surprising. And he'll actually be talking on the DevOps and Risk panel tomorrow, so you can ask him difficult questions then if you want to. So that's something to really think about. I said, automated learning is useful. It's not, automated tasks and reaches out there have really distinctive signatures in the logs. So you can figure these tools to generate work to you. Hey, we see something that looks like an attack. It sounds a lot like an IDS, except for you have the ability to actually do some correlation across devices. It's not just relying on, a single thing. You can look for attacks in your web servers and things like that. The IDS won't necessarily catch. And it doesn't have to be an ArcSight or a super expensive, dedicated SIM tool to look for this stuff. There's been a lot of work done with open source tools and Splunk and things like that. They'll get you really far with no effort. You don't need someone monitoring manually. Computers are good at repeating boring tasks, and so let's leverage them for those things so that the humans can do more interesting work, like trying to solve those identity management problems that are really difficult. Okay, so then the fun thing, secure coding. There's been a lot of bashing on developers today. I think in the security space, the only people that securely like to bash more than developers is end users. Doing security software development is really hard, particularly with a complex application. But the really nice thing is there's a bunch of things we can do to make developers' lives easier and lead to more secure code, like automated testing. A lot of things that people tend to do in the source code reviews are things that we don't need humans to do. We can identify those the basic types of things, like a lot of buffer overflows, a lot of things that would lead to a SQL injection attack or a cross-site vulnerability. We've developed some pretty good technology in both open source and closed source tools for looking for those things. So let's not waste time doing those. Automate those tasks. Write unit and functional tests that can be run every time a build is done, every time code is committed to look for those. So those developers, we pay a lot of money to write code. You can work on those hard, business logic problems. Let them, focus on the things that computers are really bad at. That's what you pay people for, as opposed to buying computers for. So let them focus on those hard problems. There's a lot of great information out there about secure code development. I could stand up here and talk for far too long about that. US CERTs publish some great stuff. Microsoft, Oracle, lots of great stuff out there on doing secure code development. But the main message here is automate the stuff that you can automate. Start when you start these reports, these automated reports. Look at what kind of errors your developers are making. If the vast majority of them are buffer overflows, don't worry about cross-site scripting right then. Train your developers when they're making mistakes. Because you know what? The developers actually care about writing good stuff. There's a meme in security. Developers don't care about security. Bullshit. Every developer I've ever talked to is really interested in security. They want to write quality code. So let them, give them the tools to write that quality code and get out of the way. I have more important things to do than babysit, honestly. And most developers don't need babysitting, and they don't want micromanaging. They want to do their jobs. So let's make it easier for them. Now, there's been some really cool work done. Actually, back in 1979, some really cool research was done at IBM, up at Watson Labs. And what they found was, as you add complexity to your applications, your code gets exponentially more complex for every time you add complexity to your application. And one of the cool things in here, if you do a little basic algebra, is that a series of smaller changes generates significantly less complex code than one big set of changes all at once. And yes, we did that, and then years later, we came across this idea, and this idea generated through the DevOps methodology of continuous deployment. And what this means is that you consistently deploy your application in small, consumable chunks. It may be 5 lines of code, maybe a couple hundred lines of code, as opposed to here's a patch that has 500,000 lines of code in it, or 50,000 lines of code. Well, one of the things at the end, you have an application that's significantly less complex. Less complex code is more likely to be stable. It's more likely to be secure. It's more auditable. That's pretty cool. But you combine these small little deployments with your automated testing, and then suddenly it's very easy to get a report out. This developer checked in this code at this time. This unit test broke on this 3 lines of code. You now know who to call and say, hey, that code you checked in this morning broke this test. Can you please fix it? You're not delaying a deployment. You're not delaying a release to a customer by nearly as much. And you can also some local research found that the longer a developer is away from a piece of code, the harder it is for you to figure out why they wrote the code that way they did. I guess particularly that around 2 or 3 days. But it's also a small spike, I think around 4 hours. I think it was 4 or 5 hours. So suddenly you're getting your development staff, whoever's doing it, whether it's a sysadmin writing infrastructure-oriented code or developing application code, they get much faster feedback, which means they just spend less time figuring out why they wrote the code the way they did, and work on fixing the code to whatever degree it is. Or look at that and say, that's a false positive. Let's fix the unit test so we don't actually tag that false positive. And code becomes more auditable. So all in all, you're getting some significant improvements of both time to market, that's money generally, but you're also getting higher quality code that's less complex, more easily auditable, more secure. The other advantage of these small deployments is it is significantly less likely that any one change will break your application. And if it does break your application, it's going to break it in a very easy to identify way because, oh look, I pushed 10 lines of code and the server went down. I wonder which lines of code broke it. You're also probably more likely to be backed out in an easy format. Or what a lot of large organizations do is they have 2 sets of servers and they deploy the code to half of them, and if it breaks, they just point the load balancer at the old set of servers. So you're rolling code out, and you're switching back to your old server. So there's a lot of cool operational things we can do here, both that may or may not be security specific, but that end up with operational and security improvements as a side effect. And I'm all about side effects, positive side effects of security things. We like to talk about unintended consequences to security of doing things. Well, there's a lot of good unintended consequences of doing these things as well. Even though we find it's much fun to snark about them as it is the things that go bad. And what this is leading up to is DevOps. I talked about automation, I've talked about metrics. These are things that come up a lot in the DevOps movement. But perhaps the most important thing from a security perspective is not the automation, it's not the metrics, it's not even the data sharing, it's this culture of openness and ability to work with each other. This really struck me because I can't tell you how many times I've heard developers can't write good code, developers are lazy, developers hate security. Look, if that's your attitude, no wonder you don't have a good relationship with your security people. You probably also don't have a good relationship with your auditors or legal or operating or anyone else. It's not really that hard to say, I'd like to help, or what do you need, or where are your pain points here? Where can we make security better without making your life more difficult? There's a lot of stuff out there. I've covered some highlights here, but really the best thing to take out of this is go in with an open mind and trying to make make it a team effort. There's no reason to be antagonistic. It's fun to be antagonistic. Who doesn't like being antagonistic sometimes? Especially after a few years, but that doesn't make for good business, and it doesn't make you, the security person doesn't need fear. And in fact, you're much more likely to be effective when you can demonstrate that you're willing to give feedback and work with folks in a pleasant environment. So that's probably the biggest thing with DevOps. And this doesn't just apply to development, it applies to legal, it applies to audit. You want to make some real success as a security person, make friends with your audit team. Audit teams get money. When the auditors go to your CEO and say, you need to deploy X tool, or you need to do the following tasks to be compliant with our operations, the CEO says, here's a check. When the security will show up and say, we want this, we want the same exact thing, it's even more likely, oh, you just want new toys, or you're being, it's all FUD, because we generated that attitude with the executive team. Auditors means money lost if we don't do what the auditors said. So become friends with your auditors. Understand what they're going to tell the executives. Talk to them about what your goals are, and often you can get the message you want communicated to the executive staff through someone who gets a little more respect from the executive staff. And over time, that actually helps build your own credibility with them as well. And so recently it was International Topic of Pirate Day, and that's fun and entertaining. So I'd like to propose that one of the best things we can do is have talk like a C-level executive day. Learn to communicate to the executives in their terms. And it doesn't mean, is it helpful to understand what a profit loss statement looks like? Would an MBA be helpful? Probably. You don't need to go that far. What we need to do is you want to get, it's like, I told you my story before about completely failing with the VP of engineering to get this patch done. If I had gone to the CEO of that same story, I would have gotten thrown out of the room. I wouldn't even have the conversation. So what I ended up doing in the long run is I sat down monthly with the VP of engineering and with some other folks. I said, explain to me how you craft messages to the CEO and the CFO. You have an engineering problem that's going to cause a delay in the product, or you want to get a change that may have some monetary impact. How do you communicate that in such a way that it is understood by the business? Things like it. And so they went and said, hey, cool. What you need to say is, here's the general issue. We don't need to go into technical details, because generally they don't care. Here's what I want to do. Here's my belief of what the financial risk to the company is if we don't do this. Here's the cost of the company if we do this in the short term. And let them make, now they have actual data, it's at least estimates, if not solid data to work with. It is easier when a customer says, if you don't do this, I won't renew my contract, and that contract happens to be worth a lot of money. But still, you're talking in terms of the business cares about, not in terms of the technical details of the problem. And it shows that you understand sort of the general overarching problem that the business is dealing with. So I would like to propose that we do something like, talk like an executive, a C-level exec day. Maybe we can come up with, funny hats or something to make it more entertaining. And on that note, if there's any questions, feel free to throw them out now or grab me afterwards. Thank you.
So, not a question, maybe a remark. You mentioned a couple of things, how to make things secure, so pushing the patches, secure development, and so on. But there was one that was missing in my I think what's rather important is the way we are dealing with the legacy systems. Because there was a study by Outpost and by, I think, Kaspersky, that most of the big hacks is not done by latest zero-day vulnerabilities. They are the old ones. And right now, even if you have patched all your system, I guarantee you that somewhere, someday on the floor, you have still Windows 2000 running your server. You cannot actually do anything with this because business say, as you said, the business rules, and they say, yeah, the application is there, it has to be there till 2020 because that's our contract.
Right.
So what do you say about this?
Okay, so legacy systems, are indeed a problem. In a lot of cases, you end up on systems that, they're not being supported by the vendor anymore, so you can't get the latest security fix for it. There are some things you can do. Some things you can do are, sometimes you can actually firewall those systems off and minimize contact. This is sometimes where technology does help. There's a variety of firewalls and virtual firewalls that could address, some of these issues. I'm not advocating typical product from personal experience, but like tipping point claims, sort of virtual hashing, there's a variety of products that do similar things to deal with those. One thing that I've seen be fairly successful is virtualizing those services onto more modern operating systems. It depends on how often that system gets used. Sometimes you just need to sort of hold your nose and say, that's a risk we're going to have to take. We have to have this application up and running for the next 10 years. It will never run on anything more modern than Windows 2000. You can't patch it. A good example of this in a lot of cases is medical systems. There's a lot of MRI systems out there and CAT scan systems running on Sonos 403. They will never be patched. But by the way, you still need access to them, to get those images off them and onto another system. And you can only firewall them so much. You can only limit network access to a certain point, and you do the best you can. And you monitor those systems. You monitor. You watch. You look for things to happen, and you hope for the best, prepare for the worst, and do the best you can. In the end, if someone wants to hack you, they're going to hack you. You're just trying to make it as difficult as possible, while minimizing the pain and suffering that the users have. So I don't have a magic attributes rather than, you know, monitored, right?
No, the point was just to add it to your token.
Absolutely. I mean, that's part of this, you know, that's part of that configuration engine. You got to know what you have. You got to know that's even a problem. How many times has someone walked into an organization and found out, you know, there's a server running something, you know, some server you've never heard of, right? Something about under someone's desk. Like, that's one of the research that came out of Verizon several years ago was that it wasn't the speed of patch management that mattered, it was the breadth of patch management. And you were, because the average, you know, vulnerability that's being exploited was like 6 months old. So you were far better off, you know, putting effort towards making sure you're patching as many systems as possible, as opposed to as quickly as possible. Like there's literally, unless you're dealing with like browser vulnerabilities, you have weeks and sometimes months, if not longer, to patch these systems. So make sure you're getting them all, as opposed to, well, I got them all done in 2 days or 4 hours. You know, that's the thing. So, but you know, I'd much rather have 2 weeks and 100% compliance than 2 hours and 50% compliance. Yeah, especially if you don't do anything about it after that initial run. There was a over there.
Hello? Hello. Just apropos legacy systems, you can't really do anything with already fielded stuff, but I feel like looking at the problem space, we should have a public policy stance that if you're going to have software patents, then we have to have publicly mandated code escrow, so when your company goes out of business, we can patch your ship.
Okay, that's an interesting idea. We have 2 questions back there.
So in your talk, when you just talked about patch management, you said getting them all is more important than getting them quickly.
Mm-hmm.
On the other hand, you're still talking about the idea of prioritizing patches. And I think we should do away with that idea. I mean, there's only 2 priorities in patching. It's, oh my god, it's a browser patch and I need to do it now.
Mm-hmm.
Or, there's patches out, I need to do them. And that's basically it. And people seem to live off this idea that you see the publications all the time. It's a quiet patch Tuesday, there's only 3 patches.
Right.
And then it's a big patch Tuesday because there's 17 patches. If I talk to the operations guys who have to do this work, they don't care if it's 1 or 17. It means patching the entire street, doing the work, cycling it through power down, making sure it all comes up right. And, well, yeah, they do care if there's a .NET patch there because these things take forever, but otherwise it's not harder to do 1 patch than it is to do 17. Not really significantly harder.
That's true that's generally true at the operating system level, except for organizations. So I work with organizations where they say patch comes out, we wait 24 hours to make sure that it doesn't get re-released by Microsoft or whoever the vendor is. We install it, if the machine stays up and running, we push it. We don't care if it's a CVSS 2 or CVSS 10 or Microsoft or whatever, we just push it out. We're not going to worry about it because we can't trust the scale of the scoring system. And for those people, it doesn't matter if there's 3 patches or 17 patches. With a few rare exceptions, like things like .NET that are a little funky to deploy. Where it gets more complicated are organizations for whom they have extremely complex testing procedures for each patch that generally cannot be run in parallel. So suddenly, and I've worked with organizations like, we have to run out these 18, these 12 environments, run the following 5 tests, and we're going to do them in serial. And so, in 1 patch, so 17 patches takes 6 times as long as 3 patches. And so that's where it does become problematic. Where things get really interesting is when you get to application patches. There's generally a lot less trust in the quality of them, unless it's coming from a couple of particular vendors. If you're dealing with financial organizations, generally you have a very small window which you can deploy those patches, like Oracle for financial organizations. Often you can't patch the financial system except for 1 weekend every quarter, and Oracle's got a lot better and made their patching process a lot easier, but it used to be you had to take the entire database down, so you had to schedule downtime for that, install it, test it, run all your sorted database tools against it to make sure performance and all these other things weren't impacted. So it becomes a significant problem. Patch management is still a significant problem for a lot of organizations, and for the organizations who it is, installing a lot of patches is a lot harder than installing a couple of patches, and so they literally have to prioritize patches. I got into a big argument about this at BSUG, because my attitude not is, most of these patches are going to be good, and I'm going to break the environment in a way that I know I broke it, rather than wait for someone else to break it in a way that I don't understand. But for the people who don't really have a really well-tuned patch-proof environment, this is a significant problem still today, and it's really depressing, and it sure as hell isn't fun. But what could be and should be for other organizations a non-event is a significant fire drill. Monthly, weekly, quarterly, whatever schedule they're on. That was a question right behind you.
Yeah, just first one remark on the legacy systems. We used to think in systems that they have to be high available and 99% up. Deal with the fact that things are going to be breached and prepare for that. Like he said, that's what you can do for legacy systems. Make sure you back up, you can restore it, you can put it online again, all that stuff. So it's not because you can't make it secure that you not have to be prepared. My question is actually, you mentioned on the config management systems, which obviously I love, but the current systems, they rely on collecting the facts on the system itself, meaning the system can lie about its facts. So how do you go to deal with that fact? Same with logs. The system can be sending logs, partly logs, fake logs. How do you deal with that?
Oh, that's an excellent question. This is actually still a hard problem in a lot of cases. When you deal with virtualized systems, VMware released a handful of tools that you do sort of external monitoring of the state of a VM, including its configuration. I think they call it a safe or something like that. This is still a very difficult problem. That once you have a compromised client, you have to sort of at some level trust the client to a certain extent. That's where having good external monitoring, sort of behavioral analysis of what's going on, network monitoring, so you can select some other external indicators of compromise works. But I'd say for just that recent organization I've worked with, that's been like, ooh, we should really figure out a way of dealing with that, but it's so low on the priority list compared to everything else. Much harder problem, much easier problems to solve that are causing a lot more pain at that point. But getting back to the legacy systems, this actually, I was reminded, is that most of these legacy systems, in my experience, need to be available for 10, 15 years, but they don't necessarily need to be available 24/7. Often it's like a financial system from some acquired company that you need it available in case the SEC calls up and says, provide me this record from 4 years ago. And I was working with one organization, we were working on our disaster recovery business continuity planning, and we said, okay, here are the systems that we think need to be available, 5 nines about time, and we're going to make them redundant across multiple data centers. Like, well, we need our business, we need, and so we had their, the corporate web servers and the finance systems and our internal CRM system. And then sort of tier 2 was like email, a few other things, and we went to the execs, and the execs said, it's all wrong. Email is business critical, it has to be up 100% of the time, along with the CRM system. And I said, well, and finance can be down. And I'm like, but order management and payroll and paying bills. And they said that can be done for weeks. I said, really? They said, well, we can take orders. We have a manual process for taking orders. We've done it before. Let's just dust it off. And if it goes down, we can manually take orders for a week. We're not selling widgets here. We're selling enterprise software. It's not a big deal if we have to write things down for a week or two while we rebuild PeopleSoft. And payroll, by the way, is outsourced to a third party who actually cuts the check. So even if PeopleSoft Finance is down, or PeopleSoft HR is down for a week, you're still going to get paid. Now, if there needs to be a change to your payment because, so it won't be quite up to date if you took a vacation day during that outage, or your tax withholding statements, or you took some vacation or something, that'll all be a little bit off, and we'll resolve that the next pay, the next paycheck run, just like we do with anything if there was some other error. So yeah, so the finance system's can be down for, we'd say, 3 weeks, and we can still run with no financial impact to the company. It could be longer, it'll be painful, but this is not a significant financial impact if these systems are not available. And if it happens at year end, it would really suck. But you know what? The SEC will understand. We won't be fined if we say, well, they just said it caught fire, and PeopleSoft went down, and we won't be able to get the books officially closed in electronic record until January 15th. And I said, oh. And I was like, okay. I now have a much better understanding of the business priorities here. And I said, well, what about all these other legacy systems? And they said, yeah, that's about the same. And, when the SEC calls, they're not expecting an answer tomorrow. They like it, but they give us like 30 days. So let's try virtualizing those systems and keeping them paused. Saves power, saves hardware, and we can just fire that sucker back up, and we don't worry about hardware reliability as much because backing up the end, and it also solves some of the security problems as well. I mean, obviously, if it's a legacy system that needs to be running constantly, that's a different problem. But in a lot of these cases, these legacy systems are there because there's certain data that you can't migrate off those systems that needs to be available periodically.
We just had the case of systems lying to you, and I think that's also comes from the way we treat our systems. We still treat them as pets, and we expect them to live long. We put a lot of effort in them, we pet them, we take care of them, we water the plants in them, we dust them off. And for new systems, not for legacy systems, but for new systems, we would be far better off treating them like cattle, or like anything else that's production. Meaning that they have their use, once they have their use, you put them down, you put up new ones. And patching could be treated like, okay, shut down the systems that are out, build the systems up with new patch levels, test them, if they're good, shut down the old ones.
Absolutely. And there are folks who do, I like that analogy of treating them like pets. Each one is a unique snowflake. That causes a huge complexity problem. Dave McCrory gave a great talk on data gravity and complexity at BruCON 2013. It's on YouTube. Talking about complexity of systems, and he actually talked about we tend to treat servers as pets. You look Netflix actually has done some published blog posts, and they don't patch systems. They create new systems. They build new systems. They run everything on Amazon, so everything's a virtualized system. They build a new virtual image each time they have a change, whether it's a software change or an application server change or a patch configuration, a system patch. They just build a new server from scratch, push it out. If it doesn't work right, they kill it. There's no patching, there's no tweaking of servers. Everything's a new build. And they just launch the new ones. If they're good, they change the load balancers to point to the new servers, and they leave the old ones running for a little while just in case a new problem develops. And that's it. Akamai kills servers. Facebook does this. I mean, a lot of the more forward-looking organizations don't really, in the individual system sense, don't do patch management or configuration changes to systems. They build new systems and kill the old ones. It does make life a lot easier. When you don't ever change something on an individual system, inventory management, configuration management becomes easier, and inventory management becomes much more interesting.
Any more questions?
Thank you very much.